All right. Okay, so again, my name is Jeb Belcher, Director of Emerging Technologies at LTI. For those of you unfamiliar with LTI, we're a recent conglomeration of a bunch of different technology companies, all folded under the LORAM umbrella. We've combined tie marking service, tie inspection services from formerly GREX. We have friction management services. We have ballast services, LiDAR and GPR, OEM solutions, and as well as the time marking and navigation / automation services. So the point of this company, the reason this group has been brought together is to drive downstream efficiencies from inspection. So that's our real purpose, is to be the technology arm and move forward track efficiencies, the ability to do work in a quicker time on track. So some of the inspection systems we combine are, like I said, ballast. So we do surface and subsurface ballast, LiDARs, GPR. We do profiling, so that's tie surface with 3D laser profilers. We do X-ray backscatter technology, so we look into the ties. And then, of course, we can look at the rail service. The RIV fleet for LORAM uses rail scope systems, rail profiling systems. So we can package all this into one place, data mine the synergies between the systems, and start to combine the downstream services into automated and faster servicing systems. And so we're consolidating all these things, and we break it down into 4 components. We have inspection systems, which is a very competitive market. You've heard the last 2 hours. There's lots of groups, there's lots of solutions, and they're all pretty advanced. There's obviously the migration to rail cars. Just about everything has a rail car application now. There's data sciences and management. So data alignment, AI machine learning, data lakes, that kind of scenarios. There's asset management, which is using the information from to make decisions. So we provide tie replacement logic, for example, for our tie planning. And then, of course, there's automation, which is we've had a few projects come out in the last 3 to 4 years around automation, and we have a lot of projects in development right now for automation. And that's a little bit of what we're here to talk about today. So what it looks like, to focus a little bit on ties, you have an inspection truck at the front end of the service, and then that drives downstream actions. So we have a tie painting truck here. I've got a video of that in just a second. So that's a second pass, and that marks the ties that are going to be removed from the track based on the inspection. We have a set out service, which optimizes tie distribution based on the inspection. So that comes after the tie painting. And then we're working on machine navigation right now. And within that machine navigation, there's quite a few subcomponents, each very complex. You have area monitoring and object detection. So all these need to be done in real time. They need to be done flawlessly. And they need to be done in a manner that you trust them. So those are very complex subsystems. And the point is, if the value of your inspection services stops at the planning, then you're not really utilizing your data to the maximum. You're not leveraging the full capacity of the value of your data. So tie set out is a service we have, which you have a ramp car on the left and with a cat on it. And what happens is this train will roll up to the replacement ties that are going to go into the track. You split the power unit from the ramp. Power unit goes to the front, ramp goes to the back, and then you can drive the cat up onto the ties, which have all been stacked horizontally in the unloading cars, and you can drive between the cars and distribute ties. What we do is we optimize the placement of those ties using the information in the inspection. So we can coordinate the drop locations via GPS, via encoder, We coordinate it with the inspection data and basically the tie marks that we painted prior to the tie set out unit showing up. We can monitor these systems as they work on a daily basis. This is a screenshot of our dashboard. We can monitor it by fleet. We can monitor by unit. And this is providing a daily feedback. We can ensure that the productivity of the work crews is up to par. They're not falling behind. And this is something we're implementing across all our automation systems. So we have a video here of tie marking. So I'll let that run. So what's happening here is our system is painting green marks on the ties that are going to be replaced. In this case, some have one mark, some have two marks that determines different types of information we're communicating to the railroad. And the point of this whole system is basically PSR driven. People and equipment off track. We no longer have the need for tie markers to walk down the track. That increases safety. Allows the railroads to redistribute those personnel into other higher needed roles, and it gives the ability to create a digital footprint of what was actually performed in that day. Some of the other things we're getting into is area monitoring. So if you're going to navigate machines automatically, then you need to be able to ensure that the space around them is safe. So this system goes on an SPS train, so similar to the image I had of the TSO unit. And I'll let this video, well, let me pause it for 1 second. So what happens here is we have a SPS train at the top in this yard, and there's a LiDAR at this corner. The system is composed of more than one LiDAR. It's a wirelessly connected LiDAR network that allows you to monitor all the sides, no matter where the operator is in the car along the train. So he can be moving anywhere in here. He's connected to all the corners. And so what we've done in these videos is we've got the area monitoring system on the train looking forward. We've set up here where it says people. We're looking back with a GoPro, and our operator is going to walk in this serpentine path at the top of the image. And so in real time, our system is going to track him and throw audible and visible alerts on screen when the operator needs to look up and be aware of his surroundings. These things are configurable. They have distance ranges. The most challenging aspect of these components is track curvature and track obstructions. It can be very challenging to look down track. And to solve that, we're developing more advanced area monitoring solutions. So this video, I'll play it in just a second. So this is our more advanced area monitoring solution. So every pixel on this screen is a point that we can digitally measure in XYZ space. So we can get distance to all points. We can get size of all points. We can measure object size on screen. So at the top here, it's recognized this over here. It's a car. It's about 1/10 of the cars on screen, but it's picked up that as a car. We get an XY. These are in meters. We get an XYZ distance to it. It's got a second car. It's got a person. It's got a truck back here, and it's got another person. And it's going to track them in real time. So this is real time. This is onboard processing. And again, it's throwing alerts audibly and visibly. So I'll let that run for just a second. So again, this system is more advanced than the other. The great thing about it being a vision-based system and not a LiDAR system is we can track the rail. We can track the rail as far as it is visible, which is one of the real problems of LiDAR-based solutions. And if you're using a purely vision-based, this is not a vision system, by the way. If you're using a normal grayscale camera or multiple grayscale cameras, then you're going to have problems getting accurate spatial information, especially as the distance increases. So this is going to be the backbone of our area monitoring technology and how we're going to monitor the area around the vehicles as they move. We can also adapt this and point it down at the track itself and identify spikes, anchors, whatever we need to do for an automated tie replacement program. So the final slide I'll show you is we are packaging all the above together into automated work equipment. So we have a spike puller on the left over here. We've put this very sleek and non-obtrusive test platform on the front. And that houses our inspection technology in these two blue boxes. So we've been able to miniaturize our inspection systems, the computer, and all the cooling and environmental components we need into a small package that's field worthy. And then we have a display for the operator here, which allows him to navigate to the ties. The goal of this particular proof of concept is we're going to remove the need for painting. So again, more people off track, more systems off track. So you no longer have to paint your ties anymore to know which ones to replace. So again, this is an abstract concept. We can move it to more vehicles within the gang. We're starting with the spike puller because it's in the front of the gang, obviously. And I think that's it. I think I'm catching us up on time here. So that's what I've got for today. I'll take questions or turn it over to, I believe, Tetra Tech's next.